Yeah, I'm Gaius Mully, and I wrote the front end for Modula 2, and the talk today, as you can see, is Modula 2 new wideset implementation, performance, results, and direction of travel. So, in a nutshell, the Modula 2 front end went into GCC in, I think, GCC 14, if memory serves right, and this is really just talking about the new set types, which have just gone into GCC in the last probably 2 weeks ago, fortnight ago. So initially, before 2 weeks ago, and back in, I guess it'd be 2002, when I started implementing large set types. And in Modula 2, I mean, what is a large set type? A large set type is a set type that occupies more than one word, so typically more than 32 bits. And how do you do that? And in the original version from 2002 onwards, it was a bit of a, to be honest, it was a bit of a hack. It was a structure with unnamed fields, sequence of unnamed fields, each of which was word length, and it just set the bits. It worked quite well. Performance-wise, there was no great problem. There had to be extra patches to go into GDB to sort of just detect these anonymous fields and recognize this as a set type. And it to some extent worked, but it was at the back of my mind. It was always that this was a short-term fix, 22 years ago, and it should be implemented really as an array of byte or array of bit set, or byte set, I suppose. But there isn't a byte set type in Modula 2 per se. So think of it as an array of bytes, i.e., array of char in terms of C, unsigned char. So what this new implementation does, it follows the technique outlined in, to follow on from Jose's talk this morning, paper books. Yeah, so there's a Modula 2 standard R2 M2R10, which is 2010. This hasn't been formally standardized, but it's been out on the internet since at least 2014, if not before. So it's been publicly available, scrutinized. It's written by a former member of the BSI committee, ISO committee, and also the maintainer of Comp Lang Modula 2 FAQ for a long time. He was a professor in Canada, Rick Sutcliffe and Benjamin Koash. They did a great job, and it's very well written. In fact, I believe, I might be speaking out of turn, but so forgive me if I'm wrong, but I believe Benjamin emailed me and said that Nicholas Firth gave his blessing on it. So it was kind of nice. And Benjamin was going to publish this on it using the Springer Verlag as well, if I remember rightly. I'm not sure, whether that's happened yet or not. But anyway, so it's well written, it's well designed, and one of the there are many features of it, but one of the designs of it was to have each data type would have a library, and so you'd have all the operators as procedures, and then you could implement your add, subtract, etc. Now, obviously there are performance implications there, but I took that on board with the new wideset implementation. Almost like I suppose I wanted to follow that route, and I wanted a proof of concept, and this was going to be, well, it was more than a proof of concept, but it seemed a good design to follow. And if it didn't work out, I could always back off and implement and hand roll them as before. So there wasn't a great risk, and there was a great reward potentially by adopting this approach. Anyway, so I did that, and that's all there. There are no regression test failures between the two systems, obviously, which is good. So it's gone into the tree, so it makes calls for include, exclude, and or not, and it'll call the library routines currently if it's -0, 0. But if you choose -0 n and n is greater than or equal to 1, then actually it will inline because there was a performance penalty. I was surprised. I'm going to define some terms. Now, apologies if there was better names out there. I haven't come across them, which is my ignorance really. I'm going to say the base type operator inlining is btil, procedure inlining as PIL, and module inlining as MIL. And this
Are those front-end passes?
No, they're not. Those are just terms. Just defining some terms.
Okay.
Yes. Just to clarify, because I will be talking about inlining. You might think, oh, am I talking about inlining?
Okay. The actual inlining is made by. The actual inlining is made by the middle end in normal regular inline.
It's made by CC1 GM2. Yeah, that's right. Yes. Yeah. Sure. So with the original set type, everything was done with base type operator inlining in M2 expra.cc and it was all calls to that from M2 gen GCC, which calls it multiple times for every word in the large set. And now, with this new approach, was going to make a call to the library if it's -0, and inline it if it's -01, 2, 3, etc. So this is a typical. If you're not familiar with Module 2, I don't blame you. I mean, but I love Module 2, but I understand that it's a fairly small community. Although, thank you for turning up. The Module 2 sets is. Yeah, is a bit like that. In fact, we see this. It's interesting in Module 2 that you can see that I can see this approach has taken place in Python really, and it's not too dissimilar in this construct here with this if C in set, although it's probably obvious, isn't it? But it's just capitalization. And just on capitalization, it's a very similar technique to Jose, with algol, and with Emacs mode, which I think which I can't demo here, but anyways, so similar thing. It'll lowercase bold in the Emacs mode. You can optionally set that, or you can have the old-fashioned uppercase if you want, or the newer case, lowercase bold, given that it's sort of an algol style language. So we set the type here to an empty set. I invert all the bits, and then I exclude set bit C, which I presume has hopefully been set in the ... The ... is any code which I haven't shown, and then it does a set and between these prime numbers, etc. It's a sort of example code. So that's what you might be doing, and you could be doing more complicated things of ands and ors, etc., on really large sets. And this could be this could easily be set of cardinal. There's nothing. The language doesn't forbid any data. Well, it has to be an ordinal type, but it can be any ordinal type. So it could be a very large set indeed. And here I've obviously only chosen 65,000. Anyway, so in the new implementation, all the operations use all the library operations use byte operands. Yes, yeah, feel free.
Sorry, just a question about the language. In the previous slide, you had this. So, what's the size of the set type?
Say again, sorry.
What's the size of the set type variable?
Right, the size of the set type there is 65,000 divided by 32.
So it's like that many bytes will be allocated.
That's right. Yes,
and
each bit is a set element. Yeah, sure.
There is no runtime trickery there. Just at compile time, everything is allocated, right?
That's right. Okay. Yeah, sure. Yeah. Yeah. So in the library, which is M2 wideset.mod, it uses array of byte, and all the operations that the ands ors are done on a byte basis currently. I was going to change that to a word size operation, but having spoken to some of the back-end developers, one back-end developer, on a different subject, I'm starting to reappraise that. I have to go and have another conversation with them and see whether that's right. And I think it might be. Anyway, so I'm not sure. I'm not in my mind now. I'm hesitating on whether it would be faster. I can always try it out. Whether it's actually going to be faster if I change to word operations. It may not be. The compiler, the GCC may be so good that it understands what I'm doing, and then coalesces these 4-byte operations into one word. But I'm out of my depth when it comes to that stuff. So I need to get any back end people here help me out. No, okay. So anyway, I'm sure that that will unravel as we go on. Anyway, so what was also quite pleasing was that despite this new style of wideset and a new design of wideset, the block operators of or not are nearly always faster than the old mechanism. However, the include, as the slide says, is slightly slower. I'll come on to those. I've got some performance figures later on, which we could. Actually, maybe I'll do them now. Do them out of sequence. Why not? If I do, just go through the performance figures whilst the iron's hot. These are so the old ones are in grey and green. It's the bottom line, hopefully. So the old ones should be the bottom line, grey and green, and this purple and brown should be on top, and that's largely the case. And there's a bit of a blip there. So this is doing block ands, and as the set size increases here, so that's 100 bytes, that's 1,000 bytes, 10,000 bytes, and 100,000 bytes, and we can see there's a bit of a blip at 1K, where it's slightly slower, but all the other times it's actually faster with a new set type. Just running through them in sequence, and that's yeah. So that was the and different optimization setting. 03, 02 didn't make a great deal. Well, didn't actually make a great deal of difference to the to the pattern. 02 for not, 03 and 03 for the not, much the same. Now the only slight hiccup is the include here, where include it goes a bit slower. So that with the expensive block operations, they go much faster. But for the inexpensive include operations, which are used, I would imagine much less, much lower use case to include a particular bit than doing blocks, and those are slightly more expensive. Although it's, I mean, what amazed me on a digression is how fast the machines are going, because I couldn't believe my eyes when I realized that actually at source code level, I was seeing at source code level an operation going faster than getting more than 10 to the 9 of those operations per second. Yeah, and as given that when I was an undergrad, that I think a function call would be like you could do 10 function calls in a microsecond or something. So it is amazing that we're up to that speed. Yes, yeah.
Are you saturating? Do these performance numbers correspond to you being able to saturate the Dcache? Performance-wise, are you limited by hardware now, more or less?
Probably, yeah, sure, yeah. Absolutely. Just running on a single core with a massive cache. Yes, yeah, sure. I'm running it multiple times to make sure that it's always in cache. Yeah. So it's and the data sets are fairly small. Maybe 2 or 3 of these. 2 or 300K. So it'll all fit in the cache. Yeah. So yeah, it's the performance I think is okay. I mean, there's a hiccup certainly on include, and I can go back and look at that. But I was happy that the expensive block operations were actually faster. So what does this mean then? It means that this technique I think is okay. With certain caveats, and also then it says, then I think to myself, okay, well I do need to have O3 and have the ability to inline these various library functions, and therefore the language needs to support inlining properly. And there is a inline keyword, but it needs to be more orthogonal and rolled out to on maybe a per module basis, and make it work on definition modules properly. And so how do you do that? Well, thankfully, this is where M2R10 comes in, because M2R10, there's a section here which defines pragmas. In the ISO standard, the pragmas is an empty space. It defines an attribute and then says what's in the attribute is implementation defined. But thankfully with R10, the pragmas have been, or a lot of them have been standardized, well, semi-standardized, and de facto standardized. And one could just take, it's the same syntax, one could just shoehorn those in, and the inlining is defined here, as well as compiler options. And so what's it look like? You can do a pragma here in ISO Modula 2, which that's part of the standard. And this pragma body is undefined in the ISO standard, but it is defined in the R10. And so we can just take the R10 idea and put it in there, maybe tweak it a bit with very few tweaks, and we get inlining working for free without having to change much. Without having to make decisions outside of the Modula 2 community. So yeah, we can have it already defined as the inline pragma, and then there's also the implementation-based pragma, which is for compilers, so they can set a library, so they can set options. So we can have gm2.compileroptions.pim3, although I see from USA's talk this morning there's this STD, which might be better to use as set the standard rather than invent a different way of doing it. But I'm obviously happy to change that if needs be. And then if that's not available, the M2R10 standard says you can have the OR and then warn if that particular option is not there. Yeah, so if we do that, then that's quite nice, because it means that we can then have mixed Modula 2 language projects. So you can have a PIM. You could then have say an ISO module, which calls the PIM2, PIM3, PIM4 modules, which you could already do. But if we put the flags in there, we could actually get correct behavior. If you used Modula 2 with negative modulus operands, then in PIM3 it defines it differently to PIM4, and PIM4 is the same as ISO. So there is at the edges that the mathematical operations have different behavioral characteristics. That's all implemented correctly. But if you do whole program optimization, then it'll load in the whole of the Modula 2 universe, compile it all, and it'll give you whatever your flag was on the command line, which is not really how it should be. Obviously, if we had compiler options, then we could set it per module, etc. It also means that when extending Modula 2 to incorporate the ISO Part 2 and Part 3, I've implemented the base language, but not Part 2 and Part 3. Part 2 is about 14 eBNF rules, and Part 3 is about 39 eBNF rules. I think the original was about 160-ish, 170, which is all done and dusted. So my proposal would be to tackle the first one, obviously Part 2 first, and then obviously Part 3. But by having the compiler options here means I can cheroot my development code away from accidental inclusion with the main code base. Okay. So in the future work, the set libraries inline equivalent should use multi-word operands. I need to check that, see whether it is faster, and I also need to go back and look at Rich's talk and see if I can use vectorization for block calls, and that might be a bit of a win as well. The pragma will allow. For procedural inlining and module inlining, PIM and MIL, and the first thing to do would be to implement the generics, the Part 2 generics, and then if that's successful, then move on straight on to the to the object-oriented extensions. Get text, Bruno Hebel has implemented a Modula 2 wrapper for get text, so that should go in, and that'll produce internationalization, and then add spell checking as well, which would be a good thing to do, wouldn't it? Yeah, so I think we've had the performance. So I think that's the conclusion of the talk. Any questions? Jose?
Oh, okay. So first, thank you for the talk.
Pleasure.
And also thank you so much for the Modula 2 front end, because while implementing the Algol one, I was like continuously like, oh, how can I do this block-oriented thing? Let's go and see how Gaius did.
All right, yeah. Like
so actually, I learned a lot of Modula 2 just by actually reading the front-end code.
Well, I'm glad it was of some help. Yeah.
So also, this talk is very good news for me, because I have a problem, which is I generate too much code for certain operations.
Okay.
And that makes the front end very slow. So my question to you is, I mean, this is nice. It's good news that the performance of the compiled code increases even. But what about how much performance did you gain in the front end by actually replacing the subtrees with function calls?
Well, to be truthful, the front end itself doesn't use large sets.
No, I mean, if I understood properly, you have this data type, that has those operations, those operands, right? Operators.
Yeah.
And before you were like generating tree for those, expanding to trees, and now you are expanding to a call node to whatever function, whatever.
Right.
So what impact did that have in the front end? Speed?
Got it. Yeah. So the big impact, and there's still an impact there as well. If I didn't show here, but if I declare a set of say 0 to max card, 4 billion, then I've got 4 billion divided by 32 bytes, and I can declare that now with this new with set type, and there's no impact at all, because it's just an array of 0 to whatever, some huge number, 4 billion divided by 32, which I can't do off the top of my head. And so that the declaration. Now, if I create a variable of that, then obviously then it's and I assign that to empty set, then GCC wants to go away and create a set of loads of zeros, or an array of zeros, and assign it. And I thought, oh, this is terrible. This is a Module 2 issue, and then I did the same in C, and the C compiler also did the same thing. And I thought, great, because now there's a use in Module 2 to go to fix that. And I looked at it's Jacob's raw data type, which I want to extend to be almost like raw data block, or replicate last data element. That might already exist, so I don't want to reinvent the work. But I certainly think that would be good, because obviously if that is solved, then it can be used in C, couldn't it? And it's a win for everybody. Yeah.
Okay. And another quick question. I understand the inlining pragma feature is generically useful for everyone. But is it actually possible, when you generate the tree node, which is the call, is it actually possible to mark it for inlining?
I'm not sure. I think what there was at one point, and I can't remember what I don't do now. I don't think I even do that. I think I just generate the trees, hand it over to Gimple, and say go do.
Right.
Yeah.
Yeah, but you pass it to the Gimplifier, but because this is one case where the front end knows that it will like to inline that if it's considered appropriate by whatever heuristics are implemented in the...
There used to be a bit, didn't there, with the inline bit. And I can't remember. So,
does that sound familiar, tree inline? Or tree no inline?
Yeah, something like that.
There was, and I'm not sure if it's still there. I think it...
I don't do front ends.
Yeah, fair enough. I think it might have fallen off a few years back. Yeah. But I could be wrong. Yeah. We're out of time. Judging by the churn. Anyway, thank you. Yeah.